Welcome to this next lesson on using the Arduino to control a model railway. Today we're going to be looking at controlling solenoid turnouts, but today instead of using relays I'm going to be using Mosfets. Now, after the last video in this series where I was using relays to control the solenoids, I thought this video would be pretty quick to put together. All I'd have to do is change a couple of lines of code and everything would work. But what I discovered as I worked through this video is there are some issues to do with solenoid control that are in some ways specific to the way that model railways work. So we'll look into that in a moment. Anyway, let's have a look at the workbench and see where I've got to. So looking at the workbench, I still have the same sort of stud and probe system for controlling the turnouts. These are connected to the shift registers just as they were in the last lesson. The difference this time is with the relays, I was powering the solenoids directly from the transformer. There was no capacitor discharge unit. There could have been, because a relay will handle AC or DC. But today what I'm going to be doing is controlling the solenoids. I'm just going to control these two today, and I'm going to be using Mosfets. Now, they're on the board. It's a little bit awkward to see, but they are this sort of little electronic component here, and you can get them on their own or already connected into Mosfet modules. Now, I did a video a couple of weeks ago on using Mosfets just with the Arduino, nothing to do with model railways, but just one of the ongoing starter kit tutorials. And I showed how to choose the size of the Mosfet. So today the Mosfet that I'm going to be using is the IRF520, and that's this Mosfet here, but it also happens to be on these boards, and it is the ideal size sort of for the project that I'm working on. Now, one of the things with Mosfets that's different to a relay, a Mosfet can only handle DC. Now, we have to be careful here because the Arduino is a 5-volt board and I've got about 24 volts coming out of here. That's why I have this bus here labeled as 5 volts, this one here labeled as 24 volts. That's so that I don't try sticking 24 volts into my Uno or anything like that. Otherwise I will release the smoke. But the Mosfet itself is more than happy to handle the amount of power that the CDU puts out. Now, the goal of today's project was just to be able to touch the studs and move the solenoid. And obviously I've got these two studs moving this solenoid over here and these two studs moving this solenoid. Now, my plan was to do a demonstration with the bare component and also then use these modules. However, as I worked on the problem, I discovered that there are some issues around using the modules rather than the individual component, as I'll show you in a bit. It doesn't mean that it can't be done, but there are some problems that you need to think about. Now, as always, there will be the link below the video to go to the Digital Town site, and if you go over to that page you will find the resources and the circuit diagram for today's lesson. So going over to the site, obviously we have the circuit diagram. Click on this for the larger version that we'll look at in a moment, but also above you can see the relay version. Now, I'm not going to spend a lot of time on the code today because the code is virtually identical between the two projects. All I'm going to do is show you the changes that I made. Now, before we look at the circuit, let's have a quick look at a solenoid. This is, I think, either a Pico or a Hornby solenoid, and these work. Obviously there's a coil in here, a coil in here. When you put a voltage, when you put power through this coil, it pulls this arm in this direction, put power through this coil, it pulls the coil in the other direction. If I bring in this one, this is a seep point motor, and it works again, a coil here, and the voltage is pulled through. However, there is one slight difference between these 2 point motors. This point motor has a common feed. So you have an individual wire going to each coil, but there is either a common feed or a common sort of ground, depending on how you have the unit wired. If we go to the Hornby one or Pico one, you can have them individually wired up, although as you can see with the wiring I have here, I am still using, in my case, a common feed, or it could be a common ground. Now this is going to be very important as we start to look at some of the problems with the modules later on. So looking at the circuit diagram, we have the power from our capacitor discharge unit, and that goes with a common ground. That ground needs to be connected to the Arduino. All grounds need to be connected together. However, what we do need to do is make sure that the, if you like, the 24 volts that's going through my capacitor discharge unit does not get anywhere near the electronic components. So that 24 volts is going to feed the coils. So I have a common feed. You could have had 2 individual feeds with this particular type of point motor. With the seep version, it can only have the single feed. And then out of the other side, the connections go to the Mosfet. And again, the other coil goes to the other Mosfet. So it's one Mosfet for each coil. And then when the Mosfet is triggered, if you like, the voltage finds its way to ground through this other leg of the Mosfet. Now, the control of the Mosfet, if you like, the on and off switch, is through this connection to the Arduino. There's one for each. I'm using pins 8 and 9. And you will notice here that I have a 1K pull down resistor. Now, I tried to work out why it needs to be a 1K, but all the examples I found had a 1K, and it works fantastic with a 1K. So who am I to question that? So I am using a 1K pull down resistor. Now, it is important that you have the pull down resistor, because if this pin starts to float, as they say, when a pin floats, it means it's flicking off. It's not quite ground. It's sort of messing around. If it starts to get any kind of voltage onto this pin, it's going to switch your MOSFET on and off. So it's very important that you have the pull down resistor, so that the MOSFET is only triggered when we have a high signal on the pin, which is going to send 5 volts to this end pin. And if you like, that will then turn on the MOSFET. And that's going to work virtually the same as a relay. It's now going to allow this power to come through, and because the power is now moving through the coil, it will trigger the solenoid. Now, I did a diagram here that sort of shows how I have connected a SEEP version versus the Pico Hornby style version. Realistically, you could have that common feed. As I said before, the SEEP requires a common feed. It only has the ability to have that. In my personal opinion, from a model railway point of view, the ideal situation is to have only a single feed to the solenoid. And the reason for that is to cut down on wiring. If you've got to have 2 connections to each coil, that means you're going to use twice as much wire. And okay, it's not a big deal when it's on my workbench, but when it's on a layout, some of these lines of wires can get quite long, and you're going to finish up using, you know, a lot of meters of wire needlessly, so to speak. So in this next part of the circuit diagram, I've just shown, if you like, how I would set up a baseboard. So the way I would tend to do it is you'd have your capacitor discharge unit, you'd have got your live feed and your ground. There's two connections that come off, your positive and your negative. Your ground is going to go to your Mosfets and also to the Arduino. That's on this circuit here. I'm not going to show it on here. What I wanted to show on here was the need for a common live feed. So this feed goes to the first point motor, second one, third one, fourth one, fifth one, sixth one, depending how many you've got. Obviously, with this type of point motor, it's got to link to both coils, but you can just bridge the back of the coils with a short piece of wire. The reason this is important is if you can use this single feed, you only need, if you like, that one wire to go the long distance to where your point motors are, and then the shorter wires joining between the different point motors so that you don't have endless connections going back to the capacitor discharge unit. All we then need is these single wires from each coil going back to the individual MOSFET in the same way that they would need to go back to a relay. Now, the reason for showing you this diagram is that usually people don't tend to like so much using individual components. They sort of think, well, I could just buy the MOSFET module and I could make my life easier. Well, I can tell you, as I sort of racked my brains over the use of the module is going to make your life much more complicated, as I'm now going to show you. So here we have a module. Now, I've got two types of module on the workbench. I found exactly the same issue with both types of module. The wiring is slightly different for the one, but I'm going to show you the issue that I have. So the module itself, very easy to operate. Once again, you're just connecting to a digital pin, which is going to the signal pin. We've got a VCC, which is the 5 volts, and we've got a ground. Now, those are required for the control of the board. If you're using the individual component, you don't actually need these. But you know, there's a little LED and some other bits on here that require that. The issue now comes to the way that these modules are built. Now, these modules are not built for model railway enthusiasts. They are built for people who are almost just going to replace a relay, but they cause us an issue from a model railway point of view. So let's imagine we've got a capacitor discharge unit over here. That then has a live feed that comes in here. We've got the ground that comes in here. Now, through the electronics in the back of the board, that then creates a loop where we go out of this connection over to our coil and then back in through the other connection. Fantastic. Press the button, bang, off it goes. It switches, it works perfectly. I've had it running on the workbench. But here's the problem. Using this, you cannot have a common feed, because the feed goes to the module and then comes out. Now, what this means is on your model railway, for every single coil, you have got to run a wire to the solenoid and then back from the solenoid to the module. Now, that means without that common feed, you're going to have, just for this solenoid, I am going to require 4 wires. If I had 2 solenoids, I'm going to require 8 wires. Now, let's look at our other diagram. Using the common return system, if I have 1 solenoid, I don't need 4 wires now, I just need 3. If I have 2 solenoids, I need 5. Whereas the module is going to require 4 and then 8. So the more solenoids you have, the greater the issue comes when you start using the modules. Now, this gets even more complicated when we start to think about seep point motors. With the Hornby Pico style, I can actually go across the individual coil. With the SEEP solenoid, SEEP being sensible people only made one connection because you'd have a common feed or a common return depending how you've wired it up. So in many ways there is no way, as the SEEP motor is built standard, to allow yourself to bridge the individual coils because you've got this common return, and you need to be very, very careful the way you feed your power through, because a MOSFET only likes the power going in one direction. If it receives the power going in the other direction, you can basically say goodbye to your MOSFET. So you'd need to be very careful in your wiring, and the only way that I could realistically see how I could use a SEEP style point motor was I was literally going to have to cut the feeds off and individually solder to the coil, which is absolutely ridiculous. Hence the reason I'm not going to use that system. So the system that you want to be looking at is this style with the common feed, and unfortunately for that you're going to need to use individual components. Now thankfully, as we see in the diagram, it is literally an individual MOSFET and a 1K resistor, so it's not like you're going to have to solder lots of bits, and I would just solder these onto a piece of Vero board, probably with some nice little connectors to either, push your wires into, or some of those screw connectors depending on your preferred method. So I have scratched my head a number of times, and if anybody can figure out a way to get around the problem that I have, please put something in the comments or send me an email, because I'd love to know what the fix is. But from my point of view, the modules are a complete waste of time in this situation. And the great news is, with the individual components, if you're in a hurry, it costs me 80 pence, I think, per MOSFET buying them on eBay. If I'm buying them on AliExpress, even in very small quantities, sort of 10 at a time, they're going to cost me 40p including the postage, and obviously if I order more it's going to be even cheaper. As for the resistors, I can't even be bothered with the price because I buy them by the 100. It's basically a couple of pence per resistor. So the price of the components is really cheap and is a saving over the cost of the modules anyway. So this is one of those unique situations where model railways have their own specific requirements, and it's one of those things where the module makers have made something for a purpose, but in our model railway situation, the solution they have given us is not really the solution we want. Anyway, all we have to do to trigger these MOSFETs is to send a pin high. So let's have a look at the code and what I've done to make it all work. Now, before I get started with the code, just a couple of resources for you. I did lesson 24 on the Arduino beginners course, which was about transistors and MOSFETs, if you want to learn a little bit more about how the circuits are set up. And then the other major component today in the control panel is the shift register, and this is the CD4021BE. This is a shift in register. It's taking inputs from buttons, and that was covered in lesson 21 of the starter course if you need to look for more information. Going over to today's lesson, obviously we're using MOSFETs today, but again the code is very much based on the last lesson where I was triggering the relays. The big difference in the code is that for the relay to trigger in the last lesson, I was having to set the pin low, whereas in this lesson the MOSFET pin needs to be set high. Right, let's take a look at the code. So only one sketch today, and that is CD4021 control panel version 5. Now the goal of this course today, I'm going to be attaching the relays. What I'm going to do in the next lesson, we'll add the what do you call them, the servos, and also we'll then put the LEDs, we'll get those lighting up on the control panel to give us a mimic panel as well. Now, the way this is written, just a quick overview, the number of chips that you require, you just set this as a definition. This then sets up all the code. The pins for the shift registers, I'm using pins 7, 8 and 9, and I am using a little micro delay here that is required for the shift register. Again, this was explained in the previous lessons. The array for the it says num relays. Obviously in today's code that would be num Mosfets, but I wanted to leave the code as similar to the last version as possible, so I'm just using pins 3, 4, 5 and 6. As always, current millis is being used because this is state machine style code, non-blocking, so there is no use of delay, which means you can expand the code in an easier method without sort of wrecking anything else. Okay, setup works exactly the same as in the last lesson. Obviously, wherever it says relay pins, we're now controlling MOSFETs. There were then two sets of functions that are called within the main loop. The one is unset relay, which today is going to be unsetting the MOSFET. Now, the reason for this is that when I touch the probe on the control panel, I don't want that MOSFET to be turned on permanently, because if I was sending power constantly to the coil, it's eventually going to burn it out. All I need it to do is send a short pulse, and we are sending a pulse, and I think today the pulse I'm using, there we are, the pulse length is 150 milliseconds. So it's a very quick pulse of power to the MOSFET, and that's been more than enough to shift the solenoid. Again, if you're using this code and the solenoid hasn't quite made it, I would up this to 200, maybe 250 if you've got a bit of a sticky turnout. You'd be probably better off fixing the turnout though, rather than trying to put more power into the MOSFET. Going back to the main loop, the only other function there is this function that checks the state of the CD4021 chips. These are the shift registers that are connected to my sort of stud and probe system, and this is waiting for the equivalent of a button press. The stud and probe can be replaced by buttons if you wish, but I'm a Scrooge and I'm just using the stud and probe because it's a nice tried and tested method. Now, when this function is called on every loop, let's just go down to this, it basically draws the information from the shift registers. It then figures out, okay, what is the state of all the pins on the shift register? Has anything been pressed? And if it has, it works that down to the individual pin number. We then do a switch statement on the button or the pin that has been pressed, and then we work through, and in my case, if pin 0 in the array has been called, it's going to trigger relay 1, but only if the pin has gone high. If the pin has gone low, then I don't want to trigger anything because I'm no longer touching the probe. So I just want to trigger the relay when the pins go high. And as you can see, I'm just triggering relay 1, 0, 3 and 2. Obviously, you know, that's just the way they're set up. It's a bit of an odd order. Now, if you're going to use this code for yourself, the only bits that you need to do is edit how many of the shift register chips you are using. So if you've got 4 chips, change that to 4. And that's all you then need to do. Obviously, you will then need to change this line here. These are the pins that are connected and are driving my MOSFETs. So as I said, I'm using 3, 4, 5 and 6. If you're using a mega, obviously this could be a much longer list, but again, you need to put the number of MOSFETs you are using, and again, I'm using 4. If you want to use more, change this line here to the number you are using and add in here the extra pins that they are connected to. That will sort all of that bit out. Then the only bit that you've got to really start to do your manual editing on is when you come down to the check CD4021 chips function. And the bit that you then need to do is add in your different case statements. So you need to figure out which relay you are triggering depending which button or stud has been pressed. And obviously if you've got more stud and probes connected, you're going to need to add more case statements in. But basically follow the example of that little bit of code there, just sort of copy and paste it down and add your extra values in, and that will do the whole code for you. That's the job finished. So coming back to the workshop, this is one of those occasions where realistically the modules are out the window, especially if you're using the SEEP point motor. As I've said before, we're using a common feed, so my capacitor discharge unit is coming over on this red connection onto this rail. That is then coming across here to this little bit of Vera board, and that is a common feed to all of the solenoids. So I'm just working on the return line that is then coming back, and it is this return set of return lines here that are connected to the MOSFETs and through the MOSFETs to ground. And the results are that I can just change the direction of the solenoids at will just by playing with the stud and probe system. So that's it for today's tutorial. What I'm going to do in the next lesson is I'm going to add in the LEDs to show the direction of the track. So as I then set the solenoid, the LEDs will light up or go out accordingly. I'll probably try and add the servos in as well, because let's be honest, I don't use solenoids on my layout. My layouts are the turnouts are controlled via servos, so I'll build the system with solenoids and servos in one project. So that's it for today's tutorial. Thanks again for watching, and please, if you want to help the channel, just click the like and subscribe, because it does help those dreaded analytics that sort of get the videos watched. So next video we'll finish off this control panel, and then we'll get on to some more exciting parts of the project. Thanks again for watching, and I'll see you in the next video. Bye for now.